Hello, this is Hiba Hamad, Lamis Abu Foul, and Amira Faroukh, and welcome to Prof. Shady's YouTube channel. This channel exhibits several different Arduino projects made by students, and in this video we will introduce you to what Arduino really is. So, do you consistently hear about the Arduino but never know what it refers to? We use the Arduino a lot at the Shady American International School in multiple useful and advanced projects. We use it because of many factors that will be discussed later on in this video. Arduino is an open-source physical computing platform based on a simple microcontroller board. A microcontroller board is a circuit board that has a chip on it that can be programmed to do several things. You can read information from sensors and tell how bright, hot or cold, and/or how crowded it is in a room. You can also tell exactly where on the globe your project is. Using output, you can control devices or display and store data. You can simply make your sensor blink an LED to give information, or you can hook it up to a power switch tail to connect your project to electronics such as lamps or other appliances. You can also display text information using LCD readout and also store codes in your computer for other purposes such as processing.
These were just small projects that you can do using the input and output. And here's an extremely simple project that we put together for you. First of all, we're going to discuss the Arduino Uno Board, which looks like this. Okay, for accuracy we printed out a bigger picture. The heart of this board has a Atmel Atmega 328P microcontroller chip, which is the largest component of the board. It has 32 kilobytes of memory and operates at 16 megahertz. It's a microcontroller development platform. We use the Arduino Uno board along with the IDE program that you can download from arduino.cc, and we'll show you that later. We use that to make projects. For the board to respond to the outside world, we are given 3.3 and 5 volts of regulator and a USB connector, which is this one. We connect it with a USB cable simply like this, and then connect the other side to a laptop or a desktop computer, whichever source you want to connect it to. There's also a reset switch that allows you to start the program all over again. And even if you turn off the board after you program it, the program will remain in the microcontroller chip that we spoke about earlier. Therefore, if the USB cable disconnected, like this, then the program will remain and the board will do whatever you told it to do, even after you reconnect it. This means that you'll avoid losing the programs that you have programmed your board to do. Above the microcontroller unit that we just discussed, you can find a set of digital pins that provide 0 to 5 volts of digital input or output. Below the microcontroller unit, you can find a set of analog input and power input that you can connect sensors that read the surroundings and return information to the board too. Now, you don't directly connect the sensors here. You connect them to a breadboard that looks like this. Now, the breadboard has these slots that you can connect jumper wires to and sensors to. The sensor that we used here looks like this, and it's a temperature sensor for the surrounding environment. So this project that we did here is a temperature sensor project for a room or a finger. We connected the jumper wires to the breadboard and left one line and then connected the temperature sensors to the board. The red jumper wire here is connected to the 5V power input, which is shown in this picture, 5V. The orange one is connected to the A0 analog input, which is shown here. And the green wire is connected to the GND power input, which is shown there. Now, this arrangement, as I said before, will create a temperature sensor project. Okay, other than the 5 volt power pin that we just talked about, there's a 3.3 volt power pin, and these two are either custom made and require you to build them, or ready-made boards that can do several things and are programmed to female headers, which are these and these that are on either side of the board. Basically, you can stack other boards on top of this one to increase the function of the circuit that you're programming, such as a Leonardo board, or another Uno board, or 2 Leonardo boards, or whatever you want. So you can do several things using several boards, or several things using one board. It's all your choice. There's also ICSP, or in-circuit serial programmers connectors. Normally, an external piece of hardware which is used to connect the microcontroller is written in C language, which makes the project a little bit complicated for beginners. However, the unique thing about Arduino is that there's a preloaded software that allows you to use a simpler or intuitive programming language to program and install programs on the Arduino chip, which is this one. Okay, there's also a USB access, and there's a smaller microcontroller on it, thus adding functionality to the Atmega chip. So you can connect a USB to it, or you can connect a microcontroller on it, a smaller one, obviously. Now, we're going to show you how to actually make practical use of the Arduino, such as this temperature sensor project that we did. So please continue watching to see how to download the IDE program from arduino.cc.
Now we're gonna show you how to download Arduino IDE. First, go to arduino.cc. Then click download. Then choose your operating system. In this case, we have Windows 7. We have already downloaded the program, so I'm going to cancel this download. Don't worry, all you have to do is install the program to make it work. Now I'm gonna open the program.
Always start by saving your program to avoid losing information. Arduino programs are always saved in a folder with the same name as the sketch. The sketch is what Arduino calls the program. The next step is making sure you're programming the correct type of board. Now that we're sure, we will start programming our Arduino. The job of this program is to make the LED on pin 13, which exists on all Arduino boards, blink on and off every second or every 1000 milliseconds. This means we don't need any external circuitry. Begin by naming your program or just start coding. Every Arduino program must have two methods in it. The first one is void setup. Its content goes inside brackets. The second part is void loop, which must exist but can be empty. The first one, which is void setup, determines things that will be done once at the beginning of the program, and the second, or void loop, will tell the board what to do continuously in a loop forever as long as the Arduino is on. The second method's job is what is normally asked of Arduino. We're going to initiate pins as outputs. This is usually commanded by pin mode in the void setup, which makes certain pins on the board outputs or inputs depending on the program. Make sure you end every line with a semicolon. The loop is going to turn the LED high, or on, wait, then turn it low, or off. Then repeat forever as long as it is on. This will continue forever as long as it is on. To do this, we use a command named digital write. We will use a delay which is programmed by milliseconds, so we'll insert 1000 milliseconds, which is equivalent to 1 second. This is only valid until the next command is due. Void loop causes the Arduino program to go into a literal loop, hence its name. After you're certain of your Arduino coding, connect your laptop or your desktop computer to your Arduino using a USB cord, as shown next.
Okay, so now we're going to use this USB cable to connect our Arduino board to our laptop. We connect one end to the laptop and then the other end to the Arduino board. And then the Arduino lights up.
So after you plug in your Arduino board, you have to upload your programming code. Sometimes, though, you might have a problem uploading, and that is probably because your software is not up to date. Follow these steps to update your software and upload. First, go to Control Panel, select System and Security, then System. Select Device Manager, go to Ports, select Arduino, check out the driver, click on the Update driver, browse to find your selected Arduino software, and that is the one you installed. As you can see, ours is already up to date, but maybe yours isn't. So make sure it is. Now that it is updated, you can upload your program. So after we're done uploading our program to our Arduino board, we can see the program working. The LED on pin 13 blinks on and off every second, or every 1000 milliseconds as we've programmed it to do. As you can see, programming using Arduino is very convenient and straightforward. We hope that you have learned the basics of Arduino and that you will consider giving it a try. Thank you for watching, and please subscribe to learn more about physics and Arduino.